let me show you how to quickly visualize data, and with this we will conclude. So all this is very interesting to be able to access the data, but probably you don't have yet the tools to visualize anything. So I've been telling you that you will be able to make plots and things like this. So let's have a look at how this goes. So again, in this example, in number 3, you can go through the different cells and we can load again our example test. So here between tabs in Jupyter, or in Jupyter Lab in particular, you don't share the data. So the data that is contained in this notebook is not shared with the other one. So here I'm gonna load this other test, and we're gonna start plotting some data quickly. Okay, so data is loaded for all 3 devices. You see that that didn't take that long. And for instance, let's say that I want to plot all the noise readings for the 3 devices. So I run this cell, I tell it I want to plot all the devices, noise, and paint it in here. So you run the cell and okay. So here we have, in this case, you see that the plot is not very good, as we have, for instance, data at the beginning of 2020. Let me just plot, for instance, just one device. This one was a little faster, and here we see that we can plot the data very quickly. Of course, you can make plots that have different axis and way for actually seeing this data. Let me walk you through that. Let's imagine that we want to do that and have a little bit more of advanced formatting. So in this case, we're going to plot, for instance, the noise again, and the CO2 data and the temperature in 3 different subplots with a particular date range, and have a title, and maybe even add some decorators, for instance, some extra text on the plot itself. So here already we have maybe a nicer looking plot. So we have 3 subplots, the noise, the CO2, and the temperature, and some extra annotations that you can customize and move, and already even store as a nice PNG file for you to use on anything. So with these instructions here, we can save it. And quickly, let me show you. So this plot that we had here, now we have it on a high quality image on that we can put on any document. And this, as you can see, has quite good resolution, and is plotting data, for instance, for a couple of weeks. If you want to analyze data maybe in an interactive way or in a faster way, let's do it with this device. So you can run this command and you will get a interactive plot. And here you can zoom in and have a look at data in a more detailed way, or include, for instance, other for instance, data that in this particular case, for instance, we are plotting 3 months of data very, very quickly. And you can see the resolution of this data is a minute resolution, unlike the dashboard earlier. and it doesn't really take that long to plot odal match data for noise. So this showcases the speed in which this happens. That is quite an interesting feature, especially for being able to navigate data quickly, considering that each of these little dots is 1 minute of data. Some other type of plots, of course, are possible. For instance, you can do scatter plots in case that you want to analyze correlation. So here we're plotting temperature versus humidity, which is obviously an inverse correlation. This is just a demo example, but you can see that they are inversely correlated. Or if you want it as well, you can maybe create some plots that could, for instance, show a time series plus a scatter plot on the right side, so that you can compare the data sources, or other types of plots, for instance, like a heat map. For instance, we're going to plot here CO2 data on one of the devices and in a daily basis with intervals of 2 hours, and we can see the time distribution of CO2, especially in an indoor space where you can see that from 8 to 8 there's more activity, and in weekends there is less activity, or in holidays, and you can see here how fast it is to perform them. Other types of visualizations, just so you can see the power of the tool, is, for instance, to compare noise levels in different categories, so prior to or after a date, and analyze the distribution, or even some comparison, for instance, on noise levels, which could be any metric, of course, in weekdays versus weekends comparison. So in this example, we are doing distribution analysis on how noise is distributed on normal days versus weekends. And as soon as it shows, you will see, for instance, how different devices show different levels of noise distributions. Each of these groups is a device, and each of the columns is weekends or Mondays to Fridays, and on the different devices. So for instance, in this case, in the device in the middle, you see that the noise is very high and very concentrated on 80 decibels and on weekends, whereas on weekdays is very much spread, and that there's a little bit more of homogeneous distribution on still high levels. And on the right side, you see that we're on a very quiet device on that end.